So let's get to it. This is the chart house, the chart table and the nav table. The charts are kept up here.
Training charts here. Oh, sorry.
Yeah.
In here, we have our old charts. We don't just throw them away. We keep them as training charts.
And you can see that they're marked here, training.
So we can mark them out, make
And
mistakes.
when we get new ones in, the old ones become training, and the new ones we don't mark up unless we're on a voyage.
Right, we use them for official.
And you basically use a grid to find yourself. It's not any different with charts. And by the way, the only difference between a chart and a map is that maps are for land and charts are for sea. So there are some other different features about them, but I mean, what makes it a map or what makes it a chart are basically the charts are for the ocean. So the grid system that we use on charts is latitude and longitude. That's how I remember that latitude has to do with up and down. Okay? So north to south is latitude. And longitude was the problem in navigation until the middle 18th century, 1700s, when the chronograph was developed that would accurately keep time. Because in order to position yourself east and west, you have to know the time. And if you know the time, it's pretty easy, because there are books that you can look up that says the sun is directly overhead at this place on this day. You know, so you just watch the sun until it gets to the top, and then when it starts to go down, and then you get the height, that gives you your latitude, and when it happens, it gives you your longitude. That's about as much as I know about celestial navigation. We won't talk any more about that. So when we're charting, we basically use latitude and longitude. And anybody have any idea about what our latitude is roughly here? Or longitude?
118.33.
30 something.
What was that?
118.33.
Yeah, there's actually a latitude 33 shop in Avalon. Okay, that's an easy way to remember it if you've ever been to Avalon. And 118. So we're north of the equator. I don't have a globe. I do have a star chart, but if you can imagine this as a globe. We've got the equator and the North Pole, South Pole, and so we measure north in degrees from the equator to the North Pole, and we're 33 degrees north. 33, about a third of the way up to the North Pole. And we're 118 west. What's the natural starting point for east and west? Yeah, not natural at all. It's just arbitrary. At the time that it got standardized, Britannia ruled the waves. And they had the best charts. So that's kind of how it got standardized. Greenwich, rather than London, because there was an observatory there. And so on our charts, we have the latitude and longitude along the edges. And you can see here we've got 33. Okay, and here we've got 118, and there's a subunit. So you've got the degrees, and what's that subunit mark? It's just a single little dash, and it's minutes, yeah. And about the only thing in common with time it has is that it is 1/60th. I mean, there's no other, really, other than it's a division of a degree, and there's 60 of them. So you get 60 minutes to every degree, making it from the equator to the North Pole, how many minutes? You actually have to multiply it.
Yeah.
He'll tell us.
Well, you got 90 and 60, so it's 5,400. You got 2 zeros in number. 5,400. And oddly enough, that's the number of nautical miles it is from the equator to the North Pole. All you have to worry about is the minutes. And here we get look, and we've got, what's this number right here? I can't read that.
43.
And this is 44. And between how many of these little ticks have we got? 10. So each one of these is a tenth of a minute or a tenth of a mile. And between 43 and 44 is 1 nautical mile. So we don't, although there is a scale here on the chart, we never need to use the scale. All we need to do to get our nautical mile is to put our divider on the mile marker and measure it off. I want to know how long the breakwater is. You know, I can measure it. You know, from here to the knuckle is, there's 2 miles. And then when you're trying to get the remainder, you close this down and you take it over here. So I've got 2 and 0.12, something like that, okay? And that's basically how I get the paper, and from it I will write down 3 things. I'll write down the latitude, 33 point, call it 38.2 and 118. What do we got here? 16.5. Okay. What's the third thing I write down?
Time.
The time. Because in navigation, I'm on a moving object. I'm on a ship. And so what's important, I can never really know where I am. I can't really plot where I am at any given point. I can only plot where I've been at a specific time. So I have to write down 0918 or 0917. 0917. And when we're navigating, we always use the military time. So if it's afternoon, at 12. And then I go to plotting. So in order to plot, I find the nearest line of latitude or longitude. Start with latitude. The nearest line of latitude to where I want to go. So I have 38. I made a bad choice. Call it 41. So here is 40, right? 41 is actually right here.
Just want to borrow these.
What's that? And 0.2. So 41.2 is 2/10 up from 41, right?
Yeah.
So I put my dividers on that 2/10, and then wherever I'm going to put this, if it's long enough, I can actually go right to the edge. If it's not, then I use my dividers to put it where it belongs, okay? And I'm somewhere on that line. That's where
Where you want to be.
that's where I want to be. And remember our grid. What I need to find myself are 2 lines. So here is one of those lines. I am somewhere, I was on that line at 0917. I'm also on another line, and that is the 118.16.5. 118.16. Now here, I'm getting bigger going north. Which way am I going bigger this way? Away from London, it gets bigger. So it's 16.5. That's here. And from this line, was right there at 917. Okay? And I put my little mark. So if I take a sighting...
Are these both the same thing?
Yeah,
They're both compasses.
They're both compasses.
They're both hand-bearing compasses.
Okay.
And the other way to do it is with binoculars that have a compass in them. Now, if I were out here somewhere, I would be sighting on things like Point Furman, like the lighthouse at Point Furman, or the light at Point Furman, or the lighthouse here, okay? And I would get an angle. How do I figure out where I am from that angle? Check, make sure I'm... So, if I come to my compass rose right here, I take an angle on it, I move the parallels by holding one steady, moving the other leg, moving this, slowly. If I mess up and tilt, then I have to start over again. And if I have the angle, then I move the parallels to the thing I'm sighting on. So if I'm sighting on LA light, here's LA light, and here's that angle I observed, I'm somewhere on that line. I need one more line of position to find out where I am.
Well, let's say 330. So you
Okay.
set it on 330?
So I go to 330 here, 330,
Right.
and then I walk it over to whatever it was that I
Whatever you
was
were
sighting
shooting
on.
at.
So that now that 330, that angle 330 is now from that point that I observed.
Okay.
I am somewhere now on that line.
Mm-hmm.
I just got that one sighting through the fog. Oh my God! What else could I use to find another line of position? Well, I'm here right off the coast. I could read my depth finder, and in my mind, I could kind of imagine the contours because it gets deeper going away from the shore. So that would give me roughly another line, another point on the line. Wherever that line crosses whatever my depth is, I've got to be somewhere on that line, right?
Sure.
I mean, if there was a mound and there were two places on it that were the same depth, then I'd be a little lost. But if it's, you know, directly shallowing, then I've got a good idea. Also, because readings from a moving ship and my plotting might not be so great, I oftentimes take 3 positions, and then I will get typically not a place where the 3 cross, but a triangle. And I assume I'm in the middle of the triangle because the errors kind of average out. Parallel rules. Try and hold them down where the cork is, and move them.
There it is.
If you slide completely the wrong way, you can reverse them like this, and then, you know, just remember to hold down tightly on the one that's standing still and only move the other one. I sometimes find it easy to lick and then wet the corks to make them a little bit stickier.
I think I'll pass on that one.
But seeing as how everybody's probably done the same thing.
Yeah, I mean,
On my own charts, I don't have me to worry
young
about.
soats, I had brown. See the
Can
brown?
you go through
Yeah.
some
Yeah,
of the, yeah.
Yeah.
hold on, Bobby.
Now the
Sorry.
other
Only
technique
one at a
is to
time.
use this one here, which has a protractor on it. Unfortunately, the protractor is only in degrees, so I can only work with true on this one. I'd have to make my corrections for variation and deviation first. But if I'm trying to advance it, I can put it here, and then it's a parallel rule, and so it keeps itself parallel as it moves across here, as long as I keep tension on here. So it won't turn sideways. These rollers keep it rolling in parallel. You can try that too.
I want to go back to something.
So we've got these numbers floating.
Very good point. Those numbers that are floating. What are those numbers?
Are those depths?
Tips.
Yes, and what are they in?
Fathoms.
Well,
Unless
look at
it's
the bottom of the
designated.
chart, in the
Where's the
center of the
legend?
bottom, it says something. The bottom center of the chart.
Feet.
Soundings in feet. Now, your only thing that you're going to see there typically, it's in 2 places,
Hey,
the bottom and
everybody.
center of the
Good to
chart
see you.
and the upper right-hand corner.
Okay.
And
You gotta read that first, make sure you're using
exactly,
the right
and then the
term.
charts, you're going to read, on US charts, they're only going to be soundings in feet or soundings in fathoms.
But you need to read that before you
Exactly, because otherwise you're going to be wrong by 6, right? Fathom is 6 feet.
Okay.
It's the, when they were pulling up the sounding line,
Arm
they
spread.
spread it out.
6 feet length.
6 feet, the length of a grown man's reach. So some other things. Do you see any SHs or Ms
I see an S.
or S?
There's an S.
Okay,
HS.
okay. So those are the type of bottom. Because if you throw your lead line over with tallow, or actually modern day they use peanut butter, throw your lead line over and bring it back up, in the bottom will be stuck whatever's on the bottom.
Okay.
And we need to know about rocks. What that grows only on rocks and not on mud or sand or shell? That we will see on the surface. That we will see on the surface.
Kelp?
Kelp. So if we see kelp, there's 2 things we can assume. 1, the bottom is rocky, and 2, pretty much we're at 10 fathoms or less. Okay? Around here, the water visibility is not good enough for kelp to grow. There's not enough light below 60 feet for them to start to grow on a hold fast. So typically around these local waters, if you're seeing kelp, you're in 60 feet or less.
And rock.
And it's on rock because it can't grow on anything else. What is the typical traffic that comes down the coast? In order to prevent encounters of the large steel kind, we have to be concerned about our local traffic. This is one of the busiest ports in the world, and we have a lot of ship traffic. And they are outside this line, constrained by their draft to a narrow channel, which is one of those things that gives them greater priority than a sailing vessel. Not under command, restricted in ability to maneuver by the nature of its work, constrained by draft to a narrow channel, and vessels engaged in fishing with gear in the water. All of those have more priority than a sailing vessel. And all of them could be power vessels. Okay? But all of those have more priority than we do. The only thing that we have priority over are power vessels and seaplanes. Our Navy requires canned fish served promptly at 7. That's the way I remember it. There's also precautionary area. This is where the ends of the traffic lanes end. The large ships are required to navigate in the vessel traffic separation scheme. Okay, which is 4 miles wide. It's a mile for the northbound, a mile for the southbound, and 2 miles in between. So they keep the vessels 2 miles apart, at least 2 miles apart. Theoretically 3 because they'd be in the center of their channels. And where those end, where the north channel, the north lane and the south lane come together, they come together in the precautionary area. When we leave LA Light, we have to call the vessel traffic service and say, we're entering the precautionary area, we're bound for 2 harbors, we'll, or we're out for a day sail. Let's talk about what that means. FL, flashing, G, green, 15S, every 15 seconds, 18M. Oh no, 73 feet. Okay, that is its height above the water. Actually, mean low water, because that's what all these depths are measured from.
At low tide.
So you have to make adjustments for that. Why would the height of the light be important?
Well, to do with the depth.
Depends on how far you are.
Well, yeah, actually, if I had a sextant and I knew and I had my charts, I can get the height above the water. I can get that height and read it off, and it'll actually tell me how far.
Brightest lighthouse. Would that be the one up the Point?
Vincenti.
Vincenti,
Point
yeah.
Vincenti light.
Right,
Okay,
yeah.
the Point Vincenti light is a group flash. It'll say GRFL, group flash, and that's you can see that actually from 2 harbors.
Just up the way on the way to Redondo.
When we're on a voyage, particularly overnight, we plot our position. So we're going to draw our positions, and from each position point we'll draw a line, so that we'll have our course over that last half hour, which is when we plot our points. We use that because we need to adjust for certain things. What do you think those things we have to adjust for?
Current.
Current and
Side slip from the wind.
yes, drift. Because if we're a sailboat, we're being pushed by the wind, and the forces of the wind are pushing us sideways as well as forward.
It's a vector.
And so we're not going where we're aimed at. We're always going a little bit downwind of where we're aimed, unless we're going downwind. If we're going downwind, there's no side forces on us. So with the wind abaft the beam, we don't usually have much drift, but we still have to account for current. And the typical current, anybody know what the typical current is through here?
It's west-east.
Yeah, it's west to east at about what, roughly half a knot. Now,
Okay, number 1, 33 degrees. 42.5 minutes north. You don't have to just put north. There you go. And 118 degrees. 15.1 minutes west. That's the first position.
That's the first.
Second position. 33 degrees. 41.3 degrees north. 118 degrees. 12.7 degrees west. Okay, and this last
Hold
one.
on a second. What was the degrees on?
118. 118 degrees.
Okay.
118. The last one will be 33 degrees. And that's the latitude. We're in a long. That's the latitude. We're going to start with 33 and 118. 33 degrees. 43.9 minutes north. 118 degrees. 13.4 minutes west.
All right, who wants to go first?
So what you're going to do is when you find it, put a dot on the spot, put a triangle around it, and label it 1, 2, and 3, and I'll come and check it.
Okay.
If you have questions, I'm here.
All right, who wants to go first?
But confer amongst you guys can help each other out. If you get stuck, let me know, and I'll try to help you out of it.
118.
You can go ahead and pull those little red things off of that'll make them stick better to the chart.
Oh, okay.
Detectors.
Oh, I see. So
33 is going to be this one.
118, 15.7.
Take it right here. Take it.
So 33.
Right here.
33. 42.5. So that's
41 is right here.
42. Do you want it? 118.
Yeah, that's 118.
41.3.
They're all way. Okay, no. 15 west.
So an easier way to do it would be to line up the bottom one. I mean, well, you know that this is 41.
Right.
If we have to
Line
move
it up with
it, line it up in case it's like way over there. So this is 41.
Just use it as a
There's
straight
10
roller.
in between. So that's
33.
1, 2, 3.
33. 42.5.
That's the line. Right here. And then what's the
Right.
west?
So, okay.
So now you can hold this one, walk that back over.
Can I show you a technique?
Yeah, well, I'm doing it as a school teacher. That's where they intersect.
Yeah.
Okay,
Well,
so
so we know.
what was it?
Okay,
So,
so
yeah,
we're going.
so we know
We
it's
got
like
33.
So we know this line is straight, right?
Yeah.
So all you have
That,
to
hold this, and now we'll move the top
do
one.
is
And you can actually go like this.
line this
if
guy
that
up
weren't
here.
there.
All right.
But you have to understand that this
Yep,
is going to be
there. Now you're
33
still on the
degrees.
same
There's
line.
variations of the
Yeah,
33
this whole,
degrees.
see, that's why they put it up in a few
Right.
places. They put it in a few places so you understand the whole scope is 33.
The whole line.
Oh, okay.
So line up with this straight line because we know it's a flat edge. Now what you're going to do, and we know that it's parallel with all the others, and you're going to go up to, what was it, 0.5?
5.
It slides off, so just come down this way. 3, just as a D parallel.
3.
12.7, go up to 0.5, like so. And we'll, oh! What's the other one? What's our other coordinate?
118.
118,
15
15
west.
15.1, so we know it's in here, right? So all you gotta do is come down here, just draw a line right here.
So you come straight up here.
There you go.
No, just draw a line straight across the edge. We have a straight edge, we're making a new parallel line.
What are you talking about? Then just do this?
Yeah, right on the edge, there you go. See now, when I take it away, you've made a new one of these, right at 42.5. So all I have to do is take your dividers,
Do you want to
come
turn
here,
it around?
Just
measure 15.1,
43.9
which
was
is not much,
Yeah.
right there, like that. Come back down to the line you created, and you find yourself right there. Right here. Right at the light. That was not position.
Straight. So you got to find
Now,
find that.
I should say
parallel line.
safe course. Is that a safe course?
That's into the light.
Okay.
Okay, and
Straight up and down.
Okay.
Yeah, that's
Now
what's there.
follow your 15 line up
If
to
it's
your
the shell,
to your drawn
that's all
line.
okay,
Where's
drum
your
roll.
drawing?
Right here, right here.
Yeah, remember it's in fathoms, so that's
You said it was in, no, it's in feet.
It's in feet.
Oh,
Yeah,
Here you are.
Right here. So
Ta-da,
that's
you
ours.
found it.
What's our draft?
And that's
Twelve.
one.
12.
So,
What?
All right, so who's on the helm first?
sure.
So we have a couple ways to do this. Okay. Right now we're on a slight right turn or left turn. So why don't you bring the rudder amidships and make it go straight? There's two ways you can do it. You can look, see if we're still turning, and you can keep going from turning by just turning until it stops. Or you can look down at the wheel and at the rudder indicator, which is right here. And the rudder indicator is pointed forward. That should be theoretically when we're going straight. It's kind of hard to tell because it doesn't move much, so you compare it with this spoke right here. Look right here. Here. This spoke right here is our king spoke. So this is theoretically midships. Now you might notice, look ahead, it's still sort of turning a little bit. That's just momentum. Alright? There is a slight walk in the prop that's turning a certain way, and it comes off. It's starting to move a little bit. But that's going to be your two tools to determine if you're going straight. Number one, of course, is your eyes. Everything else is all theoretical. Like your chart plotter, the compass, all this stuff is like, if you just look at that, you'd be like, well, theoretically, I should be not hitting these rocks. Theoretically, I should be going straight. Your eyes and what's actually happening out here. And I know that sounds sort of obvious, but you'd be surprised how many people just bury their faces in the electronics and in the equipment. Forget that. Just I'm going to just give you a few helm commands here, just kind of give you an idea of what we usually say. With kids, I make it pretty simple. I just call these the spokes, and I'll say 3 spokes to the left, 3 spokes to the right. Technically, I guess it should be port and starboard, but we usually say left and right rudder. No. Yeah. Yeah, left and right rudder. We don't usually port or starboard. So, let me, why don't you give me, so come right easy. Come right easy. Yeah, it's one command to you. Just put a little bit more of a turn on it. Now again, there's other things that will affect the rate of the turn, is how fast we're going. We're going pretty slow like we are now, like 3 knots. You're going to have to put more helm on to affect the turn. Okay? If we're going really fast, we're sailing really fast, we only have to turn a little bit. Okay. So put a little bit more, come right more, come right more. Alright. Then when I want you to go straight, I'll say steady she goes, right when and I won't be looking at the helm, I'll be looking at where we're going. So if I want to point at that big building up there, as soon as I see the bow coming close to where it's going to go, I'm going to say steady she goes, you just say steady she goes, you bring the helm back to midships. And that's when it turns good. Like if you know I'm going to be saying that, you just look at the helm, spin it quickly, and you get it to midships. And even if you have a little momentum, it should stop. I should be able to call and tell you, steady she goes. I should anticipate how long it's going to take for you to get back there. Starboard. Okay. So why don't you go straight now? So steady she goes. Come left easy. Come left hard, actually.
It's tacking.
Okay, steady she goes. I'm going to try to avoid this elbow. Come right easy. Might be cool to, you might want to look at our steering gear. That might be kind of interesting. This is technology here. It's called worm gear. Same gear, same type of gear that was in all the T-clippers, stuff like that. It's a simple playing screw thing that the rudder post goes right down through there, and the rest of this, the other piece of equipment is where you put the emergency tiller in case this rudder breaks. Okay, so let's look ahead from we got
Tug coming.
down here. So have our radio up, so if he calls us, we know what we're doing. And a lot of the times, 90% of the time, they don't call you on the radio in here. So what we're doing here is we've got to make sure that we're doing a lot of nonverbal communication. By holding our course, we're telling them, I'm leaving it up to you to maneuver. You know, and we're kind of going down the middle of the channel. So, and usually these boats, they're a lot more maneuverable than us. And generally, the power boats are more maneuverable than sailboats. So they'll usually get out of the way before. Usually. But technically, we have no more right of way on this channel than he does. We're both power boats.
We're supposed to pass port to port, right?
Yeah, we're being set down a little bit. It's okay. I'm trying to get a little bit over to the starboard side of the channel.
The radio they use is what, channel 14, 15?
The traffic control tower is channel 14.
Okay.
And then bridge to bridge, so boat to boat, is channel 13.
13, okay.
So that's
13,
how we
14.
communicate.
So he'd
But-
call you on 13.
So I can guarantee you that it's always good to check the coast pilot to see what channel your board, your harbors are communicating.
It's like Catalina. The two harbors, the harbor patrol and the shore boat is on 9. But in Avalon, the harbor patrol's on 12 and the shore boat's on 9.
Huh.
Okay, come hard right. Hard right. And you go till it stops. Then you say hard right rudder. Hard right rudder. Okay, now I want you to correct it. Get us back. Steady she goes down the channel. Come in. Fireboat. Remember, it was our nonverbal communication.
Yeah.
And we're kind of sending him some mixed signals.
DWI.
Yeah, right. Bottom of the boat, you know, the full, it's a full keel. So the main part of the full keel goes about till...
Better midships.
Okay, good. Right about to the after side of the galley house. And then it starts to kind of slightly curve up. And that affects the steerage a lot, because the less keel we have in the water, the more that part of the boat is going to want to drift around in the water. So if there's any wind, the bow is going to go, you know, blow right off, just because there's not as much wood there biting in the water. I'm going to throttle up a little bit, and I'm going to have you do the same thing, go right, we'll switch out. Okay, so I'm going to come over by these, let's go by, maybe by the corner of the Iowa here, and I'll tell you, you're going there now. You're coming right easy. Okay, and I'll tell you when you're going to want to reverse your helm. That's another thing I'll say. So, like for instance, now this is off throttle. Like for instance, if I want to go ahead and give me like 3/4 of the way over to the starboard, 4, to the right. Trying to keep it consistent here. Okay, good. Hold that. Now I'm going to say reverse your helm, and you're going to take your helm and turn the same distance on the other side. All right. Okay, reverse your helm. Look forward, still going right. That's all momentum. Even though you know your rudder's still in the water. Now it's biting. Now it's turning. Steady she goes. Steady as she goes. Okay, steady she goes. Oh. That's another one. We could do that. Okay, here's a good one. So, check it. So, what happens? What happens? It's kind of hard to do when there's no sails up. But so what we're doing is we're sailing, and I want to see how high the boat can point the sails up at any given time. I'm going to be, and we're like, we say we want to set that course all the way to Catalina. I'm going to be looking at the sails to see when they start to luff. When they start to luff, that's as high as when they start to flutter. That's as high as we can get into the wind. That's the closest we can get. But I want to go as high as we possibly can. So what I'm going to do is that you'll be driving, steering, and I'll be looking at sails. So I'll be looking, we'll be turning, and I'm going to say, come right, and I'm going to say, we're going to mark your helm. We're going to come up, and I'm going to say, when I see it start to level, I'll say mark, and you're going to see what course is, and then you're going to correct, and you're not going to go no higher than that course. You see, it's kind of hard to demonstrate in this. The closest we can point into the wind will be that point of sail. All right, and any given day it changes. And it's pretty typical out here. You know, you usually get a southwesterly wind between here and Catalina, and it's pretty steady most of the time, but it'll change. And yesterday it was pretty variable, varied about 20 degrees or so.
Whitecaps.
But that's what I mean. It's kind of hard to demonstrate here, but so why don't we do this? Why don't you give me 4 spokes to the left? All right, and then and then watch the compass while we're coming around. Okay? And then while you're looking at the helm, look up at the bow and just kind of get an idea of the pace that it's changing. It takes just a little bit of a lag time. The compass, it's kind of like, imagine it's on a spring, you know, because it is like a magnetic spring, right? So it'll take a little while to catch up to where we're actually going. Okay, steady she goes. Bring the rudder, and it's stopping just the easier, but it's still turning, you know. Slow down. Slow down. That's all momentum, just a little bit. Okay, that's pretty good. All right, let's switch off. Let's get someone else. Awesome. Thank you. Okay.
We look out for things that we could possibly hit. Would be our hazards navigation, which would be other boats, which would be basically anything in the water we could hit. Rocks, logs,
Crab traps.
all of that. All of that. Swimmers, exactly. Exactly. Your job, being on lookout, is going to be the captain know where those things are. For some reason, it wants to make sure you guys know how to take a bearing with a handheld bearing compass in here. On lookout, you never use a bearing compass, but because he wants you to know, we'll get it out at least. You guys all used one of these before? These are actually very simple to use. This would be your handheld bearing compass. If I wanted to take a bearing, I can find out what the bearing is on the bait bar. Hold it up to the channel. Right at the bait barge, and right under the barge will be a number. And that will be the bearing of the bait barge. You won't be doing that, you'll be using relative bearings. And relative bearings, the bearing of the object relative to the boat. So a relative bearing, it breaks down just like the compass, north, south, east, west. We have dead ahead, dead astern, and on the starboard and port beams. Those are our north, south, east, and west.
Do you use degrees, or do you use like 1 o'clock, 2 o'clock?
It's points.
Points.
It's just like if you box a compass, there's 32 points. There's 32 points of relative bearing. It breaks down even further from your 4 directions to quarters off, so that you have dead ahead, then you have broad on the port bow, or broad on the starboard bow, then you have on the starboard beam, then you have broad on the starboard quarter, then you have dead astern. Port quarter, port beam, broad on the port bow, dead ahead. And the way it breaks down even further than that is in points. And the easiest way to figure out a point is just to hold your hand up like this and make a fist. Basically 1 fist is 1 point. 2 fists, 2 points. Just like that. Numbers work. Because the way the numbers work, off of dead ahead, it goes 1, 2, 3. 1, to know is direction, which is the relative bearing, and distance. The captain will want to know where is it and how far away is it. So that speedboat right now, I'd say, is on the starboard beam. Yeah, 400 yards. Relative measure, the way I do relative measure, because you usually use it here when you're docking. Line 1 usually has called out distances. The thing that I always keep in mind when I'm calling out distances is the distance from basically the pin rail right here to the back of the boat is 90 feet.
90.
So the distance from the pin rail to the main mast, 45 about. So use that, look back, okay, that's 90. How far away is that?
Got it.
That's
That's
the-
much better.
Exactly. Bow watch is when you're calling distances, then just be consistent. Even if you're wrong, stay consistent. The captain will make adjustments in his head. What he really wants to know is his speed of approach is important to figure out. So if he can tell you're off by 30 feet, as long as you're consistently off by 30 feet, he'll be okay with that.
And that's the cat head. Sure, it's got
That would be
cat
your
head.
cat head. Yep. That would be your other cat head.
What'd you say the distance is to the lighthouse right now? Quarter mile? Half mile?
That's about a mile, isn't it?
Yeah.
A mile?
This entire breakwater is 2 miles long. Important. It's one thing, you know, when you're talking about the sailboat all the way out there. Then, you know, you're off by a mile.
He's not going
it's
anywhere.
Not that important. The captain needs to know what to look out for. He's got plenty of room to maneuver here. It gets more important like when you're dealing with crab pots. You're going out of the breakwater here and you're surrounded by these big crab pots. He's going to want to know, really want to know, where is it and how close is it. Keep it consistent. Rather than yelling stuff back, we'll do hand signals. Yeah, exactly. You guys know the hand signals?
Nah.
Sailboat, motorboat, crab pot, and jet ski or flying asshole.
Flying asshole.
Actually, sign language, I found out.
Oh, is it?
Yeah.
Really?
Yeah. Outside of some sailor made it.
Yeah.
It's real.
Really
Wow,
sign
I
language
like
for
it.
jet skis?
No,
Oh,
asshole.
For asshole?
Flying
Flying
asshole.
asshole. So, then basically you've already got it kind of established. Let the captain know, you let him know there's a sailboat.
We never use the walkie-talkies.
You're on a voyage.
Timer ready?
Ready?
Everybody ready? Okay.
Cookie ready?
Big splash. Floating along. Floating, 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 floating.
Time.
Stop.
1.78 seconds.
Okay.
That was a fast cookie.
Got the placard. On the back here, we have the formula. Written out. It's not the fastest formula, but it is the simplest formula to understand. Okay? So, we take the distance, which was
10 feet.
10 feet. So we have a distance in feet. What was our time?
1.78.
1.78 seconds. So we're going to put 10 over 1.78 seconds. And you have a calculator. Yeah, the 1.78 seconds should be on the bottom. We have a calculator. You can feel free to use it. And you're going to divide 10 by 1.78. We take that answer and we multiply it by 60. We get what?
About 300.
Well, we get feet per minute, like generally, feet per minute, and then we take that answer, we multiply by 60 again, we get feet per hour. Okay, so let's do that. I have a
5.6.
Yeah, you can. I mean, we'll get some working calculators for the kit, but you could just have them do working calculators. It's not a big deal. So times 60 equals 337.
Some of those fenders.
0.07, so let's say 0.1. 337.1. Take that number. Times it by 60 equals 20,224.7. Now we're doing nautical miles, so 6,076.
Right about
6076. What'd you get?
Oh, I didn't do it.
Oh, yeah, 3.3. And then you get your speed, which in this case I was walking at a flash speed of 3.3 knots. Which got me to Catalina Island in about 12 hours.